Uh, so we are going to continue with the scenario. So next we are going to discuss about the suspended bodies. So we already seen the sliding blocks. So the suspended bodies, we have a simple freely suspended, and also we have a combination of a suspended with the sliding blocks. We'll see that in this particular one. So in this, the first thing is we have a suspended body. So we have a cord which is attached to the block. So a block weight is been acting downwards, and due to that we'll be having tension as well. So in that case, when this particular thing is moving upwards, so you will be considering this as a motion positive. So we don't have any other forces involved in this, so it will be just T and W. So in this case, summation of forces will be so T minus W. So we will consider the positive for the motion direction. So in the second case, we have the same scenario where the tension is there and you have weight. So these are forces, but the motion is in downwards direction. So that will be considered positive. So in that sense, summation of F is equal to W minus T. So based upon the motion direction, the symbols, the sign convention changes. So additionally to that, now we are going to see the suspended body which is moving in this with a combination of sliding in the block in an inclined plane. So that will be case 3. So we have a suspended body sliding in the inclined plane. So this is theta. You have a tension. So we have weight which will be acting in the vertically downwards. So we have theta, and this W will be divided into two components. That will be W sine theta, that is W is the self weight of the block, and this will be W cos theta. Okay, so considering the motion is in the upward direction, so this will be considered positive. So the force, we have a friction because the sliding taking place, so it will be against the direction of motion always. So these are the forces which is involved in this particular case. So when you are taking the summation of forces, so we are going to take the upward direction, that is in the respective to the plane, upward direction. So we are going to consider that as a positive one. Okay, so in that case T, so T is in the same direction of motion, T. So against the motion is going to be minus W sine theta and then minus FF. So where FF is equal to mu into NR. So NR is being given by the summing up all the perpendicular forces in the to the plane. So the only perpendicular force that you have is a W cos theta. So that will be W cos theta. So when you expand the FF value, so T minus W cos theta minus mu into W. Sorry, one second. This is not W cos theta. This is W sin theta. So this will become W cos theta. Okay, so we have expanded the FF, which will be mu into W cos theta. So this is the value for this scenario. The fourth scenario, the same suspended body which is moving in an inclined plane in the downwards direction. So the same kind of forces will be involved. So we have a tension which is always in this direction. So we have a self weight acting here. So that will be divided. So this will be W cos theta and this will be W sin theta. So the theta is nothing but the inclined plane angle. So after this, if the motion is considered this as a positive direction, so FF is going to be against motion always. So in that consideration, so summation of F is going to be W sin theta minus T minus FF. So ff is expanded as mu into nr as usual. So where nr is in this case also it's going to be w cos theta. So when you expand those things, it's going to be w sin theta minus t minus mu into w cos theta. So these are the various cases that will be dealt with when you're dealing with the suspended bodies. So with this from the previous video and this video, we can say that these are the summation of f that has been done. So next video onwards, you'll see the problems and we'll use this scenarios to solve the outcome variable that will be used. So based upon the output parameters, we'll see it's all using all the three different methods, and we'll also see which is the effective method to solve different cases. So we'll see in the next video. Thank you.